Yo! Welcome back to the development diary of Umi, the new C-inspired systems language. Last time, we set up some of the surrounding code that we'll need for parsing the Umi language, and we discussed the very basics of Bacchus-Nor form notation for grammars, and we left off with the decision of how it is we're going to end up iterating over our source information. And I thought long and hard about it, and I think we're going to go through the manual parsing route. And the reason for that is because in the end, I want full control over uh, the grammar of the language. Obviously, we already have full control, but I want full control and not box ourselves into the system of having uh, use tokens and things like this in Elixir and then have the parser proper taking tokens. Instead, I want the parser to deal with the source strings directly, and if tokens naturally arise from our use of that, then so be it. So we're going to do that. Let's start the parsing process, shall we? So the first thing is we really will, not you, we really will need to uh, have a list of these rules just for our own reference. So I think what we'll do is we will. Ooh, what should I do for this? I think what we'll do is maybe we'll make, for the first time in forever or ever, perhaps we'll actually make a I don't know grammar.md or something. So the first thing is we'll just make the grammar for an import statement. Although, as we saw last time, this stod.io umi file will be the first to be paused inside of our for loop here. So we're going to have to deal with the rule for a function headed prototype as well. So let's go ahead and write this down too. So if I just bring this over here for now, hopefully this is still big enough. Maybe I should increase the size. Yeah. So a function, I guess this would be what? A function header. Function prototype? Let's call it function header for now. So what is a function header? What does this look like? First, we'll have the fun keyword, and then we'll have an identifier, followed by open parens. Eventually, we'll have a closed parens. And inside of here, we will have our parameter list. After we have our closing parentheses, we'll have a right arrow, and here we'll have a type ident. And then we'll end that with semicolon as well. Yep, that looks right. So we'll need to deal with this. Okay, so we have our function header. First, let's figure out what an identifier is. The identifier rule will be any, let's write it as if it was regex. So it'll be A to Z. How do you do this in the regex? I think it's like this actually. A to Z, A to Z. No, that's not right, is it? The very first character of an identifier should be underscore, and then A to Z, A to Z. Yes, and then after that, we'll have underscore again, 0 to 9, A to Z, A to Z, and there will be 0 or more of these. Also, I want Umi to have full control over the ASCII keyboard. So we'll also add in, I think I want the @ symbol to be used for labels, so we won't put that in, but I'll definitely put in the $sign, and I want to use the hash symbol for something that the compiler deals with. I'm thinking. Or do I? No, I want this to be used by the compiler, so we won't put that there. Instead, we will have the $sigil be available as a character that people can use in their identifiers. Now, that is the story for now. To be honest, I think that in this Unicode world that we find ourselves in, we'll eventually want to expand this to include non ASCII based characters as well. But coding that in at the very start will be a little bit of a headache and definitely will be something that will keep us busy for a very long time as we have to go and look at the basic multilingual plane of the Unicode standard. Then we'll have to write a Unicode parser, and then we'll also have to, well, a basic UTF for Unicode parser. And then we'll also have to deal with the fact that, for example, in Unicode, you have different character classes. So these character classes, I don't even know what the character classes for ASCII are, to be honest, but there are some characters which are designated to be mathematical symbols. And I don't want mathematical symbols to be able to be used for general identifiers. Mathematical symbols should be restricted to the names of operators. And I do want to have operator overloading in UMI, but I want the operator overloading to be limited to functions that use these mathematical symbols rather than overloading the built-in operators and causing confusion. So that is also something that I want to tackle. It's going to be something we tackle with much later. So we'll just leave it like this for now. Sweet. So I think for a general identifier, this will be correct. Yes, this should be correct. I guess we don't need these parentheses, do we? Cool. Okay, so that is what an identifier will look like. Now this parameter list thing, what will a parameter list look like? Well, a parameter list is going to be like this. So it's going to have the type. Actually, this is backwards. I miswrote my own function. A parameter, I want it to look like this. I think, did I write main like that as well? I did. So actually, UMI is going to be a left to right language, not a right to left language. So every parameter, and also I think variable declarations look like this as well. Somewhere. Where you have the name of the variable followed by a colon, followed by the type. For a parameter, naturally, the type has to be given because it cannot be inferred, except in the cases where you give it a variable initializer. And because this is already being looked for inside of a parameter list, I guess here we'll also put either const, I guess. I was thinking that actually instead of, for top level const, yeah, what I'm thinking about is I want order to be used either or with const, so that way you don't have to put the both of them there. But if we have local variables or static variables, function local variables, then if you want this to be const, you're kind of in a bit of a bind. And also for volatile as well, we'll have to think about that as well. I suppose what we could do is we could say this order itself is optional, and then if you don't put the storage specifier there, then the storage specifier should probably be on this side then, local const main. No, I want it to be like this, const local main. So when you don't have anything there, then this will be the same as order. When you do have something there, then it can either be order or local or global. That seems okay to me. But for a parameter, if we can stick const here, we cannot stick local there because that wouldn't make sense. I guess you could hypothetically put order there, but what would be the point? So we'll just leave that optional, I suppose. And volatile, I suppose you can put volatile there as well. Yeah, volatile const order argc. Yeah, that looks fine. That looks fine to me. So we'll do it like that. So a parameter list was one of these parameter things, followed by a comma. Now, in C and C++, actually, you can have trailing commas inside of array initializers, but you cannot have trailing commas in parameter lists. And I've never understood the reasoning behind that. It makes no sense to me. I 1,000% want trailing commas to be possible in this language. It just makes life so much easier. But how to actually code this up, because if we have more than one parameter like this rule is not, yeah, actually this is fine. Like this rule is not correct because this would imply that you could have multiple parameters that are optionally separated by a comma, but that isn't the case. What I actually want is something more like, this is hard to figure out how to do. Because if you get rid of the optionality, then it means you have to put a comma, which is not quite what I want either. Maybe we could have it be, we have an optional parameter. Or maybe we have it so that we have it like this. And then this is optional. Or, no. In the case where you have a single parameter, then this would be okay. But then after that, we would want it to be parameter no, because this would let you have two parameters. Ooh, how are we going to parse one of these parameters so that we allow trailing commas? Maybe we could do it like this actually. So we have parameter followed by parameter comma, and we have 0 more of these. And then the very last thing could be a parameter like this. I think this would be the right thing. So you have parameters with a mandatory comma, and you have 0 more of those. And then the very last thing is a parameter followed by an optional comma. And then this whole thing being optional means that this would satisfy the case where this is an empty list. Because if the last parameter was not optional, then it would mean that every function has to have at least one parameter, which is not the case. I guess what that would imply is we can actually, maybe we could do it like this. So a parameter list is nothing, or there is at least one parameter. That's probably the easier thing to type here. And then that would let us do this. Yeah. This would be the most sense. So in code, what this would look like is we first check to see, do we have a left paren? And then the very next thing we check to see is a right paren. If it is a right paren, then it's a empty parameter list. Otherwise, we must have at least one parameter that's followed by a comma, and if it's the last one, which we can check to see, we can check because we can always check for the presence of a right parentheses after the presence or non-presence of a comma. Let me rephrase that. If we're in the case where we know we must have at least a single parameter, we can check after we pass the parameter, is there a comma there? Or is there a right paren there? If there is a comma there, then we'll check to see after that if there is a right parentheses there. If there is, it's okay. If there is a comma there and the parameter is there, then we just loop around again. If there is a no comma and no right parentheses, then it means that we have an error there. Yeah, I think for the time being this works. Until we write the code, though, we won't know. See, this is why you don't want to just have your whole language be grammar rules. This is why you want your language to be like code as well. So that way, the code informs the grammar, and the grammar informs the code, more or less. I'm really just writing this out for my own reference. And a parameter, this is going to be, what did we say this would be? This would be type modifier, optional type modifier, followed by an identifier, followed by either a comma and a type identifier. Type ident is what we call that. Or it'll be followed by an equal sign and a expression. Expr. And expressions is where things get kind of crazy. So it's one of these two. So either you give the thing a type, or you give it an initializing expression. Now the only problem with this is if we have a function now where, for example, this might be like A, B, C, and then you have foo, which is an int, you could have the case that this is now a named parameter before or a default parameter followed by a positional parameter. And I think we'll have to deal, if we go down the route now of having things have the parameters have an initializer, then this will modifier doesn't either. If we go down this route now, we'll have to deal with the fact that we have positional parameters and also named parameters. Although at the call site, Umi will support like specifying the names of function parameters at the call site. But in terms of the function prototype, in terms of parsing, does it make sense to have these be mixed? And I'm leaning towards no, because if you pass in a this and then a this and then a this, it seems like that would get kind of hard to deal with inside of your head. What should we do? We could get around this, actually, if, for example, if we call printf, the whole reason why for languages like Python and C++, you have to put named parameters, positional parameters before the named parameters is because there's no way to signal to in the language that you want this positional parameter to take its default value. And I think if we had something like, well, it obviously doesn't make sense for format here to be have a default thing. So let's just add this here like this, and you can be a float. Remember, our float and ints they have default alias. These are aliased. So int is an alias for int32. Float is an alias for float32. If we say that float, like this. So if foo has a default of 3, and at the call site we're passing just positional parameters, we could get around this by passing in the keyword default and then say 3.0f. right? If we did this, obviously default will be a keyword in the language, so users won't be able to create a variable called default. If they passed in default, then 3 would be passed where for the argument for foo. And if we did this, then it really doesn't matter what the order is that we let the function parameters be declared in, because we'll always, at the call site, we'll always have the ability to say what we want each thing to take. Either we pass an explicit value, or we pass it in default, or we instruct the compiler to stick the default value in. I think that would solve our problem just fine. So I think we're going to do that. And by the way, before I mentioned that we'll have the ability at the call site to use named arguments, and the syntax that I'm thinking for that is kind of like how we have format followed by a colon, followed by the type. In a language like Swift, the way that you say it is that you have the name of the parameter followed by a colon. But for me, this looks too much like a function declaration. So instead, I'm going to be cheeky, and we're going to put the colon at the front. And so that way you can say format is equal to ABC, and then maybe bar is equal to 3.14, and foo is equal to 9, 8, whatever. And so this will let, I like to, in my mind, like this equal sign is, okay, make foo be 8. Whereas if I said like foo be 8 like this is too, it looks too much like a type declaration. So we're going to do it this way. And this kind of syntax has precedence anyway. For example, when you create a struct, a name struct, like, I mean, what's the classic? Stat. You can say like st size is equal to thing. So here, you would say stat dot size, like this. And so the dot comes before the name, and then we have this equals. It's kind of mirror. If you squint, it looks like it's the same thing. Although I guess we don't say printf colon format like you would say stat dot size. But you take what you can. So we're gonna go with this syntax at the call site. So that's how we'll get around our initialization problem. Okay. So that looks like it would do the right thing. The next, this is a parameter, isn't it? Type modifier, optional, followed by the identifier, followed either by a type or by an expression. In the case where we have the expression, though, do we want the ability to give it a type as well? For example, in Jai's language, in JAI, you can give an explicit initializer by saying like just colon equals. And this looks like a face. Like for example, instead of foo int there would be foo. Also, do we want to have the ability to say foo int equals 3? Because right now that's not what the grammar is saying. So really we just have a type specifier followed optionally by an initializer. You know what? I think yeah, I think that's what we're going to do. Yes, that's what we're going to do. Where are we going? Here. So instead of this being an or, instead what we're going to have this as is a optional chain. Like this. However, we do need at least one of these. So we need, even though these are both optional, at least one of them must be specified. So I guess what that means for us is it will be kind of like this. So it won't be that they're both optional. It'll be either you're required, either you're both there, or only one is there. Like this. And so even though this looks like it's three separate rules for a parameter, in essence, this is actually just a single rule. We parse the front side exactly the same. Then we just check to see, we'll have two booleans, or we'll have one boolean, no, two booleans, to say either we went into this rule or we went into this rule, and if we went into neither of those rules, we'll error out at the end. Again, this is another one of the reasons why recursive descent parsers, handwritten, are written in this fashion. Because if we were using a tool to generate the grammar, this would be kind of hard to do, actually. All right, cool. What's the next thing? I guess type modifier is the easy thing to do, isn't it? Type modifier for us is either const or volatile. Now, for a parameter, we are not putting in a storage class here, so I guess we did say maybe we'll actually allow order to be there. So we'll do that. Okay, type modifier is that. What else? There's type ident. So the type identifiers. For now, we know we'll have float, or we'll have float 32, or we'll have float 64, or we'll have int, or int 8, int 16, or int 32, or int 64. And we follow along. uint 8, uint 16, uint 32, uint 64. And we'll also have char 8, char 16, char 32, and char 64. And we did talk about other types, but I think we don't need to define those immediately right now. So have we got everything? We only are missing expr, but expr is not a very... expr is big. It'll be very big because this will encompass binary operator expressions, unary expressions, terminals, primary expressions as they're called. And I think we will leave the definition of expr to tomorrow's episode, or the next episode. So we didn't write any code today, but we began to think about how we would write some of the code. So that is a win in my book. So thank you so much for tuning in to the Development Diary of Umi, the new C-inspired systems language. I hope that looking at how one might go about creating a very basic BNF form, eBNF form grammar was informative for you and helpful for you. If you have any questions, comments, thoughts, insights, please feel free to leave them in the comment section below, and I will get to them when I get them. So, until next time, take care.